evaluate the integral. We got integral of x squared over square root of 9 minus x squared. We got a fraction. There is no fraction rule. We try for u substitution, and u is 9 minus x squared, and its derivative is negative 2x. But we got x squared, not only x, we got more than x times x. We can always manage the number like negative 2, but since we have x squared, we cannot get rid of another x. So u substitution does not work. Then we look for other options, and we identified that inside radical sign, we got a number square minus a function square. So it's like a number square minus a function x square, this form under radical sign. So when we have this form, then we can make a substitution for this function x in this case, so that we can get rid of this radical sign and possibly we can simplify here. So when we have this form, then we simplify, we always substitute u equals a sine theta. Okay, that's the case. So in this case, a square is 3 squared. So you can say a is 3 and u is simply x. Then we let x be, so a sine theta means 3 sine theta. Okay, now we need to convert everything in terms of new variable theta. So we take derivatives of both sides with respect to theta. Then dx over d theta is 3, derivative of sine is cosine theta. Okay, that means we can solve for dx now. Then dx is just 3 cosine theta d theta. With this, we can simplify this radical sign inside square root of 9 minus x squared for our use here. Let me do over on the side. Then with this substitution, the whole purpose of this substitution for now is to get rid of this square root. Let's see. That is 9 minus x squared is 3 sine theta squared. That is 3 squared 9 sine squared theta. Inside radical sign, we can factor 9 out. Inside 1 minus sine squared theta. Okay, sorry, what happened here? I don't know. Theta. Now 1 minus sine squared theta is cosine squared theta. Now we can take a square root of 9, which is 3. This is cosine squared theta. Square root of cosine squared theta is cosine theta. Oh, that's good. So with this substitution, the integral, the given integral becomes, I don't know what is happening. On the top, we got x squared, that is 3 sine theta quantity squared. 3 means 9 sine squared theta on the top. On the bottom, square root of 9 minus x squared, I worked out here, and that came out to be 3 cosine theta. And we have now dx, and dx was found to be 3 cosine theta d theta. 3 cosine theta d theta. Okay, it's good. Now we can simplify. 3 from top and bottom cancel. Cosine theta also cancels. So now what is left here is 9 sine squared theta d theta. This 9 can be pulled outside. We got sine squared theta d theta. Okay, there is no direct formula for sine cosine square cube. We don't have formula, so we cannot integrate directly. But using half angle formula, we know that sine square is 1/2 1 minus cosine 2 theta. Okay, Okay, we need to use this in order to integrate. So that is 9 1/2 1 minus cosine 2 theta d theta. This 1/2 can be pulled outside. That is 9 times 1/2, 9/2. Now we can integrate 1 with respect to theta. It's like antiderivative of 1 this time, so we pull outside. Antiderivative of 1 is x, but our variable is theta, so theta minus antiderivative of cosine is sine. But there is a number 2, so we need to divide by 2 plus c. So almost done. Unfortunately, theta was not in the original question, so we need to now substitute theta. Okay, and that starts from here. By the way, whenever we assume something, from there we need to work on a right triangle. So when x equals 3 sine theta, let me do over here, that means sine theta equals x over 3. Based on this ratio, we can draw a right triangle with angle theta, and sine is opposite over hypotenuse, opposite over hypotenuse, and this is adjacent. Now a square plus b square equals c square, so we can use that little formula, a square, that's the unknown, plus b square equals c square, that's 3 squared 9. Subtract x square from both sides, take square root, so the sides are positive, 9 minus x squared. So this side is in fact 9 minus x squared. Okay, that's side A, by the way, or don't have to write, that's why different color. So this is 9 minus x squared. Now we got all three sides. Okay, from sine theta equals x over 3, we got all three sides. We use that to finish this problem. So sine theta equals x over 3. I'm rewriting that, okay? We got x3 and this one 9 minus x squared. Okay, we want to plug in here. So this is 9/2. Okay, theta. So we need to do this inverse sine theta. Okay, sine theta equals x over 3 implies theta equals arc sine of this. So theta equals sine inverse of x over 3. Okay, we take sine inverse both sides, and by definition of sine inverse, when we got sine theta equals x over 3, theta will be simply sine inverse of x over 3 minus, okay, sine of 2 theta. Okay, here is a problem. We have all the information for angle theta, but this happens to be sine 2 theta, double angle. Then, I mean, we have two options. The easier would be to do is get rid of this double angle, sine 2 theta formula. Okay, from trigonometry, if you recall correctly, sine double angle sine 2 theta is, in fact, this is sine theta plus theta, and we can use the sum rule, and we know that sine 2 theta is 2 sine theta cosine theta. So I'm going to apply that. So sine 2 theta is 2 sine theta cosine theta over 2. So why am I writing this formula? Because then I have sine theta times cosine theta, and for angle theta I have this right triangle to replace in terms of x, because we cannot leave the answer in terms of theta. So this one plus c, as you can see, this is 2 times 2 to cancel. Now sine theta times cosine theta. Sine theta is opposite over hypotenuse, x over 3. In fact, that was given. We assume that. And cosine theta is adjacent over hypotenuse. So, and that finishes the problem. So this is 9/2 outside sine inverse of x over 3 minus sine theta, that is x over 3 times cosine theta, that is square root of 9 minus x square over 3. 3 times 3 9, but we cannot multiply inside. Okay, it's a radical sign. I would just leave here plus c as the final answer. Okay.